1. Langerhans immune cells, epithelial sentinels. Residing primarily in the epidermis, these cells act as the immune system's first line of surveillance, constantly sampling the environment for foreign invaders. Historical discovery, named after Paul Langerhans, who discovered them in 1868 at age 21 using a gold chloride stain, though he originally misidentified them as nerve cells. Antigen presentation. They are professional, antigen-presenting cells APCs, meaning their primary job is to catch, process and show pieces of pathogens to T cells. 2. Anatomy and morphology. Dendritic structure. The term dendritic comes from the Greek dendron, tree. These long cytoplasmic extensions allow a single cell to monitor a vast network of surrounding keratinocytes. Birbeck granules. Unique tennis racket-shaped organelles visible only under electron microscopy. They are formed by the zipping of the cell membrane during the capture of pathogens. Surface markers. They express high levels of CD1A and Langerhans CD207, specialized proteins that help the cell bind to and internalize complex sugars found on bacteria and viruses. 3. Physiology, immune surveillance, constant sampling. Using their dendrites, LCs perform peripolesis, constantly moving their arms between tightly packed skin cells to search for signs of infection. Pathogen recognition. Equipped with pattern recognition receptors (PRRs), they can instantly distinguish between self-proteins and non-self patterns like fungal cell walls. Antigen processing. Once a threat is detected, the LC eats the pathogen, phagocytosis, and breaks it down into small peptide fragments to be displayed on its surface. 4. Physiology. Activation and migration. The unzipping phase. Upon activation, LCs downregulate E-cadherin, the molecular velcro that holds them to skin cells, allowing them to break free and begin their journey. Lymphatic navigation. The cells enter the afferent lymphatic vessels using a chemical GPS, the CCR7 receptor, to find their way to the nearest lymph node. Maturation shift. During migration, the cell changes from a capturing machine to a signaling machine, increasing the number of communication molecules on its surface. 5. Physiology, antigen presentation. The immunological synapse. In the lymph node, the LC forms a physical junction with a T cell, presenting the antigen fragment like a key into a lock. MHC Class II. These are the specialized display trays on the LC surface that hold the antigen fragment in place for the T cell to inspect. Clonal expansion. Successful presentation triggers the T cell to multiply into thousands of identical copies, creating a targeted army to fight the specific infection. 6. The historical mix-up, nerve versus immune. Gold chloride staining. Paul Langerhans used a staining technique usually reserved for neurons, which colored the LCs perfectly, leading to a century of classification error. Structural mimicry. Because both nerves and LCs use branching dendrites to sense the environment, they represent a classic example of biological convergent evolution in form. Neuroimmune crosstalk. Modern science shows LCs actually live in contact with nerve endings, receiving chemical signals from the brain that can dampen or boost skin immunity. 7. Distribution. Primary sites. The stratum spinosum. This is the prickly layer of the epidermis where LCs are most densely packed, positioned just below the waterproof outer barrier. Mucosal gateways. They populate the moist linings of the mouth, throat, and reproductive tract, the most common entry points for viruses like HIV and HPV. Strategic gaps. LCs are noticeably less dense on the palms and soles, likely because the thick keratin layer there provides enough of a physical barrier on its own. 8. Distribution. Secondary sites. Lymph node cortex. This is the meeting room where migratory LCs spend the final stage of their lives interacting with the adaptive immune system. Thymic populations. A subset of LCs exists in the thymus, where they help train young T cells to ensure they don't accidentally attack the body's own tissues. Bronchial surveillance. While the skin is their main home, similar cells patrol the upper respiratory tract to catch inhaled allergens or pathogens. 9. Population and cell counts. Density metrics. A single square millimeter of skin contains roughly 500 to 1,000 LCs, meaning every time you touch a needle-tip-sized area, you contact hundreds of sentinels. Total body mass. If you collected every LC in an adult's body, they would weigh roughly as much as a small organ, totaling over 1 billion individual cells. Epidermal percentage. Though they look dominant, they only make up 2 to 4% of total skin cells, The rest are the bricks, keratinocytes they protect. 10. Comparison. LC versus epithelial maturation. Ectoderm versus mesoderm. Keratinocytes come from the ectoderm, outer layer, while LCs come from the mesoderm, middle layer, highlighting their completely separate ancestry. The conveyor belt flow. Epithelial cells move upward to dry out and die. LCs remain horizontal or move downward to the lymph nodes to live more actively. Lifespan differences. A keratinocyte lives for about a month before being shed. A Langerhans cell can stay in the skin for years, self-renewing locally without needing bone marrow help. 11. Clinical disorders. Overactivation. Allergic contact dermatitis. Commonly triggered by nickel or poison ivy, this occurs when LCs overreact to a harmless substance and prime the immune system to attack it forever. Langerhans cell histiocytosis, LCH, a rare condition where abnormal LCs multiply and form lesions in bones or organs. It is considered a bridge between an inflammatory disease and a cancer. Barrier-driven eczema. When the skin's physical seal is broken, LCs are constantly bombarded by dust and pollen, leading to a state of permanent, itchy hyperinflammation. 12. Clinical significance and vaccines. Transdermal immunization. Because LCs are so efficient, researchers are developing microneedle patches that deliver vaccines specifically to the LC layer for a stronger response than a muscle shot. Viral decoys. Unfortunately, some viruses like HIV use Langerhans cells as a Trojan horse, hitching a ride on the cell to gain entry into the deeper immune system. Cancer surveillance. By identifying mutated skin cells early, LCs help the body destroy potential squamous cell carcinomas before they can grow into tumors. Summary and key takeaways. Biological sentinel. The Langerhans cell is the ultimate scout, bridging the gap between our environment and our internal defense systems. Complexity of form. From Birbeck granules to dendritic branches, every anatomical feature is optimized for a specific step in the immune response. Future of medicine. Understanding LC migration and activation is the key to curing chronic allergies and perfecting next-generation needle-free vaccinations.